a 20 gram, okay, a 20 gram oscillator with a natural angular frequency of 10 cycles, okay, 10 radians per second, is vibrating, okay, is vibrating under the damping, okay, it is under the damping, some liquid or some damping medium. The damping force is proportional to the velocity of the vibrator. Damping force is proportional to the velocity of the vibrator. How it is going to start the vibrator? It is directly proportional. If the damping coefficient is equal to 0.17, how does the oscillation decays means slow downs from this liquid, slow down from the surrounding area. Okay, once again take it. Okay, for example, one support you take, this is the 20 gram, or how much weight it is, 20 gram is there. Then feel that it is in the liquid, liquid, it means the damping is opposing to this, that is R is equal to. Therefore, once again, given data, mass is equal to 20 gram, convert this into 10 to the power minus 3 you write. Okay, you will get kg, that is 0.02 kg you write. Angular frequency is equal to 10 radian per second you write. Okay, but we know the damping force, given that since damping force is directly proportional to its velocity, x is the displacement or maximum position, dx by dt is the velocity, therefore write directly proportional to this. Okay, damping coefficient, or r is equal to, given r is equal to 0.17 kg per radius. We know the general differential equation for the damping, or the mechanical equation for this vibration. We know m into d square x by dt square plus r by m into dx by dt plus k by m. This is the general solution, general equation for this vibration. Or this r, okay, or we know r by m is what, 2b, another. Okay, and k by m is equal to what, omega square. This is a fundamental, we know, damping constant. By using these value, okay, by using the value, okay, the natural frequency or angular frequency, angular frequency of the velocity is compared with the velocity of the body. Therefore, b is equal to r by 2m, you write. Okay, b is equal to what, r is equal to how much, given 1.7 divided by 2 into 0.02 is the mass of this, 4.25. so b square is equal to how much? Okay, squaring it, okay, 4 4 is 16, and then it is 18.06, square this value. Okay, from the data, number of cycle, that is how much, the angular frequency number of cycle, how much, 10 radian per second is given. Okay, or omega square is equal to 100 radians per second is there. By comparing b square and omega square, okay, which is bigger? Here this is the omega square is 100, b square is equal to 18. Therefore, always here what is the omega square is, or we can say b square is less than omega square. This is under damping condition. This condition is under damping. We know in theoretical there are 3 conditions are there. But one, b square is greater than omega square, b square is equal to omega square, b square is less than omega square. Under damping, over damping, critical. Which damping is there? Then this will say that this case is the under damping case. In this way you need to write. Okay. So another one, shock waves we will discuss some how many minutes? Wait, right, shock wave, right, take it. The distance between the two, okay, the distance between the two pressure sensors in a shock tube, okay, is 100. See what is the taking shock tube, this is the shock tube. Okay, shock tube, okay, this is the shock tube, this is the shock tube, this is diaphragm, this is the sensor S1 and S2. Okay, distance from the two sensor pressure is, this distance is 100 millimeter. Okay, the time taken by the shock wave to travel in the distance, to travel this distance, time is taken 100 microsecond. Okay, now if the velocity of the sound is given here, velocity of the sound is 340 meter, then calculate its Mach number. Very easy, calculate its Mach number. Given value is what, the distance between these two, this distance is equal to 100 millimeter. 100 millimeter means 100 into 100 into 10 to the power minus 3, okay, 3 meter. T is equal to 100 microsecond. Microsecond means 100 into 10 to the power of minus 6 second. Then Vs is equal to velocity of sound is equal to 340 meter per second. We know that Mach number is always what is velocity of sound into velocity of speed in that media or air, we can write, or Vs, what we write, Vs is the distance displacement by time. Okay, you substitute here directly, what will that, x is equal to 100 is there into 10 to the power of minus 3. Okay, t is the time period is equal to 100 into 10 to the power of minus 6 is there. Take it all back, then this is a 1000 meter per second will be there. So this value substitute in the Mach number, so 1000, okay, divided by, okay, a is equal to how much, 340, okay, then this will be get 2.94, okay, values. There is no unit because it is number, Mach number. So same way another, how many minutes over, right, same way another one, the distance between the two pressure, the same, this is a shock wave, okay, this is a diaphragm, this is okay, s1 is, s2 is the pressure gauge. Okay, the distance between the two sensors in the shock wave is 150, okay, and the 150, the time taken by the travel to distance, how much time it is, a 3 millisecond, okay, and calculate the Mach number of this above shock. Very easy, okay, same, right, what is the distance, is given 15 millimeter. 15 millimeter means 150 into 10 to the power minus 3 meter. Time is given, what is the time, 0.3 millisecond. Millisecond means 0.3 into 10 to the power minus 3 second. Okay, then same thing, Vs, we know that x by t is there, x by t you substitute the value, or you may substitute directly. Mach number is equal to Vs by a is there, Mach number is equal to Vs by a is equal, or we can substitute Vs is equal to what, x by t divided by a, or you write in the fashion of x by a divided by x by t divided by a by 1. This can be written as, x divided by a into t also, okay, directly you do in that fashion or this fashion, you calculate this first, then you substitute, otherwise directly substitute the values at. So x is equal to what, 150 into 10 to the power of minus 3 divided by how much, a is equal to 340, okay, you write a is not given, a you write word of sound in here, into t is equal to 0.3 into 10 to the power of minus 3. So remove the values, whatever zeros are there, you will get the 1.47, okay, this is the Mach number, 1.7, okay, clear.